Okay, I think this is recording. It was a student requested that I come in and explain how we got the answer keys for our radical equations day 2. So let's see if this helps out. So our technique is going to be to isolate the term that has your radical and then square both sides of the equation. So here I'm going to square the left-hand side. So to balance the equation, I square the right-hand side. So when I do that, I have x squared plus 5x is equal to 36. Now, in squaring both sides of the equation, I might have introduced answers, extra answers that do not satisfy the original equation but do satisfy this equation. I'm going to solve this equation. By factoring. If I don't see how to factor it, then I could always use the quadratic formula. But this factors to x plus 9, x minus 4. With a leading coefficient of 1, they're generally easier to factor. So negative 9 and positive 4 are my two possible solutions. So I need to plug those back into the original equation and check and see if they do in fact check. So if I plug in a negative 9 on the left hand side, negative 9 squared is going to be a positive 81. And if I have 5 times a negative 9, that's going to be subtracting 45. And the question is, does that evaluate to 6? Because the original equation says that it does. 81 minus 45 is 36, and the square root of 36 is 6. 6 equals 6, so we know that the negative 9 does check. Let's plug in x equals 4 into the original equation to see if it checks. So on the left hand side we have 4 squared plus 5 times 4, and the question is, does that evaluate to 6? So we've got 16 plus 20, and that's 36, and the square root of 36 is equal to 6. So both of those checked, and that's why on my key I had negative 9 and positive 4. So let's move on to the next one. In the next one, I don't want to jump in and square both sides of the equation right now because the term that has my radical is not by itself. I need to add 6 to both sides of this equation. And negative 1 plus 6 is 5. If we square the left-hand side, we need to square the right-hand side, but in doing so, you introduce the possibility of extraneous solutions with regards to the first equation. So we have 2x squared plus 5x minus 25 is equal to 0. So if I don't see how to factor this, I can use the quadratic formula. If you have to come over on the side and do your x method, or if you're able to look at it and say, well, 2x times x gets me the x squared, and I need two values that will multiply together to get me negative 25, but add together with a 5x. 2 times 5 is 10, and the 10x minus 5x is 5. So that's how that factors. We have a zero product theorem that says if you have a product of numbers and the product equals 0, then at least one or more of these factors must be 0 for the product to be 0. So if 2x minus 5 represents 0, then that's just a two-step. If we add 5 and divide by 2, we get 5 halves, and over here, if I subtract 5, negative 5 and positive 5 give me 0, and if 2 times 5 halves, the 2's cancel, and 5 minus 5, that gives me 0. Now, I can't say that those are my solutions yet because I haven't checked them into the original problem. So let's do that with a calculator. Let's plug in 5 halves. So on the left hand side, I've got the square root of 2 times this 5 halves, but this 5 halves is being squared, and then plus 5 times 5 halves. And that's all we're taking the square root of, so I have to move my cursor outside of the radical and then subtract 6. So if this equals negative 1, then that guy's going to check. If not, so it equaled negative 1, so hey, it checked. Let's come in and plug in a negative 5. So we take the square root of 2 times the negative 5, and that's being squared, plus 5 times negative 5. Move outside of the radical to subtract 6. And again, when we plug in negative 5, if this guy equals negative 1, it'll check. Hey, we get negative 1. So they both checked. Alright. We do not have the term that has the radical by itself on one side of the equation. We need to add 2 to both sides. So I've got this 2 times this radical, and over here I have x plus 2. So I'm not going to divide everybody by 2 and create fractions to work with. Since I have the term by itself that contained the radical, when I square it, I'm just going to have to remember that this 2 to the first power, it also gets squared as well. So you've got 2 squared, which is 4. When the radical is squared, the radical goes away. I do need parentheses around that because it was 2 times this quantity. Over here, exponents don't distribute. You'll have to FOIL it out. You have x plus 2 times the quantity x plus 2, which is x squared plus 4x plus 4. Hey, this is a quadratic equation. Let's get it in standard form and see if we can factor it. If not, quadratic formula, or we could solve it by completing the square if we wanted to practice doing that. We've got 12x plus 24, x squared plus 4x plus 4. Set it equal to 0. By subtracting 12x from each side, we've got minus 8x. Subtracting 24, we've got minus 20. So I believe that I can factor this, that I've got x minus 10 and x plus 2, and I get possible solutions of 10 and negative 2. So we've got to check these. Let's use the calculator again to check it. So when we plug in 10 on the left hand side, we have 2 times the square root of 3 times my 10 plus 6. Move on the outside of that radical and subtract 2. Now, it says that should equal x, and we plugged in x is 10, so if this equals 10, then that guy checks, and hey, it equals 10. Well, now we'll plug in a negative 2. I'll move to the outside of my parentheses. I've got minus 2. It'll equal x. Well, x was equal to negative 2, so if this guy equals negative 2, it checks. Hey, it equals negative 2. Alright, so both of our possible solutions checked, so we found the solution set to the original equation. This time we have two radicals, but as long as we have one of the radicals by itself on one side of the equation, then we're ready to start and square both sides of the equation. If I square the left-hand side, I have to square the right-hand side. And on the left-hand side, we just get 2x plus 1. Now on the right-hand side, let's write out the x plus 1 plus 2 times another square root of x plus 1 plus 2. So you're going to have to multiply these two binomials together. It might be smart to do it in a table, some organized way, whatever your favorite way is to multiply binomials. So when this radical is multiplied by itself, the radical goes away and we just have x plus 1. 2 times this, well, we have 2 of these radicals. And then 2 times that, we have another 2 of these radicals. And 2 times 2 is 4. So along this diagonal, I have x plus 5. And along this diagonal, I have 4 of these radicals. So let's write that out because we're working on an equation. We were working on the expression for the right hand side of this equation. So we have 2x plus 1 alright, and then here x plus 5. 2 of these radicals plus 2 more of those radicals is a total of 4 of those radicals. Alright, so now, up here I had a radical on the left hand side and a radical on the right. I had 2 radicals in that equation. Well, now I only have 1 radical, so it is getting simpler. We need to get this term by itself by subtracting 1x from each side and also subtracting 5 from each side. When I take 1x away, then I take 5 away, and I get this. To get rid of that radical, we need to square both sides of the equation again. So if we square the left-hand side, we've got to square the right-hand side. Now, like I say, this is x minus 4 times the quantity x minus 4, x squared minus 8x plus 16. If you have to write it out in a table, go ahead and do that. If you like spelling the word FOIL out or whatever method you use to multiply a binomial times itself, but recognize that exponents don't distribute. This is not x squared minus 4 squared. Alright, so when I square the right hand side, I have to remember that this is 4 times 4. I have to remember to square it. And when I square the radical goes away, and I do need parentheses around that. So I have a quadratic equation. I want to try and get it in standard form and either factor it or use the quadratic formula. So you do have to have the quadratic formula memorized. If I subtract 16x from each side, now here this 16 and that 16 just cancel each other out when you subtract it from each side. So I don't have to do any kind of an x method or anything like that. I just have 2 terms, and what's common to both terms is x. So we factor out that greatest common factor, that x, and we have x minus 24 left. So this product, if it equals 0, either x equals 0 or this x minus 24 equals 0. So let's check each one of these and see if one of them is extraneous. If we check 0 on the left hand side, we have the square root of 2 times 0 plus 1. Now we need to plug that in on the right hand side and see if these are numbers that are equal to each other. So here I get 2 times 0 is 0, and 0 plus 1 is 1, and the square root of 1 is 1. And on the right hand side, 0 plus 1 is 1, the square root of 1 is 1, and 1 plus 2 is 3. 1 is not equal to 3, So this 0 is extraneous. I don't know why I just didn't say extraneous. I don't know why I said x is not equal to 0, but it's not in the solution set. Alright, let's check the 24 and see if it is. So on the left hand side, when we plug in 24, we've got 2 times 24 plus 1. Now the question is, when we plug that in on the right hand side, will these be the same number? So if we've got 24 plus 1 and then plus a 2. Okay, so if I double 24, I get 48, and 48 plus 1 is 49, and the square root of 49 is 7. And on the right hand side, 24 plus 1 is 25, and the square root of 25 is 5, and 5 plus 2, hey, that's 7. So these guys are equal, and this 24 is in my solution set. Let's take a look at the next one. Well, the square root is by itself. It's just equal to the variable x. So this one should be pretty straightforward. If we square the left-hand side, the radical goes away, and we get 7x plus 8. If we square the right-hand side, we get x squared. That's a quadratic equation. Let's get it in standard form. X squared minus 7x minus 8. If we factor that, we've got x minus 8 and x plus 1. Possible solutions to the original equation are 8 and negative x equals negative 1. So if we plug in 8, what happens? Well, let's do it on the calculator real quick. On the left hand side, we have the square root of 7 times 8 plus 8. Okay. Well, hey, that equaled 8, and the claim was that it would equal x, and x is 8, so this guy does check. What about this negative 1 if we plug it in? We've got the square root of 7 times this negative 1 plus 8. So that guy's 1. But on the right hand side, if we substitute it in, it's negative 1, and 1 is not equal to negative 1. So that doesn't check, and this x equals 8 is the only value that's in my solution set for this original equation. So this time I have 2 radicals, but I do have at least one of the radicals by itself. I can never have both of them by itself because, you know, where the x has got to be on one side of the equation or the other. So with one of the terms that contains the radical by itself, we can square each side of the equation. On the left hand side, it might be smart for some students to do this in the body of a table. All right. When you multiply the radical by itself, the radical goes away, and we have negative x times that radical, and a negative times a negative is positive, and we have x squared there. So along this diagonal, those are like terms. We have negative 1 of these things and another negative 1 of these things. We have negative 2 of those things. So let's get our table out of the way. On the left hand side, our table helped us recognize that we have x squared plus x minus 2x radical x. But on the right hand side, the 3 also has to be squared, and when you square the radical, it goes away. So we have a new equation, and we still have a radical in there. See, last time we had 2 radicals in the equation. Well, We've now whittled it down to one radical. We need to get it by itself, square both sides of the equation, and see what we have here. Negative x squared minus x. Oops. When I subtract x from both sides, I'll have 8x there. Okay. You know what? Even though we are going to eventually get this radical by itself, let's get this in standard form. And I'll show you why I'm doing that. So let's move that term to the other side so it changes sign. Well, look at these three terms. What do they have in common? Well, they all have an x in common. So I know that I have x times, if I factor out an x, I've got negative x plus 8 plus 2 radical x. Okay, so by my zero product theorem, either this first factor is 0, either x equals 0, or this negative x plus 8 plus 2 times radical x equals 0. So now let's come in and get this radical by itself. And we've got 2 radical x. If we move these terms to the other side, that's x minus 8. Alright, I need to shrink this up to give me some room. If we square the left-hand side to balance the equation, we have to square the right-hand side. When I square the left-hand side, the 2 squared gives me 4. The radical is gone, so I have 4x. And over here I have x squared minus 16x plus 64. Alright. Get this, subtract the 4x from both sides. And can I factor this? I believe that I can. That I have x minus 16 and x minus 4. Negative times negative, hey, that product 16 times 4 is 64, and if I add them together, the negative 20. So I get 16, and I also get 4. So I made no mention of the 16, so let's check all of these. I have to keep pausing the video because I don't want to cough into it. I certainly hope it's pausing. Alright, let's take my equation and move it to a blank page, and we're going to check 0, 4, and 16. We need to check 0, 4, and also 16. Alright, so when I check 0, does it work? Well, on the left hand side, we've got 0 minus 0, which is 0, and 3 times 0. I don't need a calculator for that. That definitely checks. On the left hand side here, we have the square root of 4 minus 4, and the question is that equal to 3 times the square root of 4? Well, on this side you have 2 minus 4, which is a negative number, and there's no way this square root's ever going to be a negative number. We got 3 times 2, which is 6. These are not equal to each other, so this is extraneous. Let's check the 16. We have the square root of 16 minus 16 And the question is, see, that's going to be negative. The 4 minus the 16. And how could, on this right-hand side, positive number times a positive value is, we've got 3 times 4, which is 12, and they aren't equal. So these two are extraneous. I don't know why, like I say, I don't know why I put note x is not equal to 4. I should have also had note that x is not equal to 16 if I'm doing that, but why I just didn't call them extraneous, I don't know. Let's take a look at this one. So we have two radicals within, we've got on the left hand side a single term. Hey, that term contains a radical and it's by itself. On the right hand side we have two terms, but since we've got this one by itself, we can square both sides of the equation. When we square the left hand side to balance the equation, we square the right hand side. The 2x minus 14, the radical goes away. Can make a table for this and you'll see that you get x plus 2 radical x plus 1. So let's show you that that's what you get. Because eventually you'll want to be able to do that without constructing this table, because it takes time. And it's just multiplying two binomials together. So this guy is x, this is a radical x, another radical x. That's how I got 2, and 1 times 1 is 1. So this table is how I'm getting this right hand side. So we need to get this term by itself. Let's subtract x from each side. Let's subtract 1. And now let's square each side. Alright, so this is a quadratic equation. Let's get it in standard form. Let's subtract 4x from each side. Let's see if we can't factor that. 225 is 15 squared, which has factors of 3s and 5s. So I need to group, come up with two numbers from this four factors, so that when they're both factors are negative, that when I multiply them I get a positive value, but yet when I add them that I get a negative 34. So well, let's group it. I think that negative 9 times a negative 25, that product will give me positive 225, but when I add these together I'll get the negative 34. So there, we found it. So we've got x minus 9, x minus 25. So we have possible solutions of 9 and 25, but we don't know if they check yet. So we've got to plug them into the original equation up here and see if they check. I'm going to erase all this stuff to give myself some room. So if I plug in 9 on the left hand side, I've got 2 times 9 minus 14, and the question is that going to be equal to the square root 9 plus 1? So this is 18 minus 14, which is 4, and the square root of 4 is 2. But over here, square root of 9 is 3, and 3 plus 1 is 4. Those are not equal to each other, so that's extraneous. Extraneous with regards to the original equation. It satisfies the equation, after we had squared it, but to the immediate equation before it, but it doesn't satisfy the original. 2 times 25 minus 14. question is, will that be equal to radical 25 plus 1? So we've got 50 minus 14. Well, that's 36. And the square root of 36 is 6. And over here, we have 5 plus 1, and that's 6. So those are equal to each other. So this is in the solution set. This one was extraneous, but this one satisfies the original equation. All right. We do have the radical by itself. Let's square both sides of the equation. Radical goes away, and we have x plus 3. And over here, when we square it, again, we can make a table, but we'll see that it's x plus 6 radical x plus 9. Let's see if I'm right. So you can see that along this diagonal, these 3 radicals plus 3 more radicals is 6 radicals, and that's what we have. Now, when we subtract x from each side, those terms cancel. When we subtract, we're trying to get this term that has our radical by itself, and when we subtract 9 from each side, 3 minus 9 is a negative 6. Well, divide both sides by 6 and maybe be easier for you to see. This principal square root is defined to be the positive square root. So the smallest it could ever be is 0. This is going to be 0 or positive. A principal square root is never going to be negative, and that's why it's no solution or no real solution. That we can't find a value of x that's a real number that will satisfy this equation. Let's take a look at number 9. Alright, so if I square the left-hand side, I have to square the right-hand side. The radical goes away. I get 2x minus 6 radical 2x plus 9. You can construct a table if you don't believe me. Now this guy, I need to get that radical by itself, so I'm going to subtract 2x from both sides, so I'll have negative x. Subtract 9 from both sides, minus 16 is equal to this negative 6 radical 2x. Since all of these terms are negative, if I multiply everybody by negative 1, that'll become positive, that will, and that will. See, I'm afraid if I leave those negative signs there when I'm trying to square it, that I'll just make silly sign errors. I'm going to square the left-hand side and the right-hand side of this equation. So over here, x squared plus 32x plus probably 261. You know what? I always forget what, even though Mr. Cook told me the other day. 256. And here 36 times 2x, because the radical goes away. Alright, so I have this 32 x's minus 72, a negative 41. No, I keyed it in the calculator wrong. 32 minus a 72 should be negative 40. Yeah. Alright, so I need to factor that. So for me, I have to sit here and think about, I have to break 256 down into smaller numbers. 256 is 16 times 16. We solve that. 16 is 2 to the 4th. So this is 2 to the 8th. If we raise 2 to the 8th power, 2 raised to the 8th power is 256 now. So I've got these all these factors of 2, and I need to group them together in such a way that and each factor is going to be negative because the negative times negative is positive, so that when I add them together I get this negative 40. So I think if I group this guy like this and call this guy negative 8, these 5 factors here is negative 32. So we already know that product is positive 256, but we add them together we get the negative 40, so there it is. So we've got x minus 8. Well, I could have cheated and looked up there and saw the solution that I copied with it. Alright, so I get x equals 8, x equals 32, and I need to check both of those. So let's plug in 8 and see. So we've got 8 minus 7 on the left hand side. Well, that's going to be 1 because the square root of 1 is 1. And we've got 2 times 8 minus 3. Well, that's 16, and the square root of 16 is 4, and 4 minus 3 is also 1. So this guy checks. (32) minus 7 is 25, and the square root of 25 is 5. On the right hand side, when we plug in 32, if we double 32 we get 64, because see it says 2x, so 2 times 32 is 64. That's 8 minus 3, and 8 minus 3 is 5, so this one checks as well. Alright, so let's take a look now at number 10. If I square that and I square that, I get x plus 2. Over here, if you have to construct a table, you'll get x plus 1 plus 2 of these radicals plus another 1. So I have to get this term by itself. Well, I know that 1 plus 1 is 2, and that 2 and that 2 cancel each other out. I know that if you subtract x, those cancel each other out. So I have 0 is 2 times x plus 1. If I divide both sides by 2, 0 divided by 2, 2 divided by 2 is 1. If I square both sides, if I subtract 1, I get negative 1. So let's see if that checks. On the left hand side, we've got negative 1 plus 2. That's a positive 1, and the square root of 1 is 1. On the right hand side, we have negative 1 plus 1, which is 0, and 0 plus 1 is 1. So this guy does check, and that's in my solution set. Alright, let's take a look at number 11. Now this time, it's more like the other day. We don't have an extra term over here. So when we square both sides of the equation, the radicals go away, and it's nice that we have 5x minus 1, 2x plus 8, subtract 2x from each side, add 1 to each side, divide by 3. Now I have to check it. When I square both sides, I could have introduced an extraneous solution. So on the left hand side, we have 5 times 3 minus 1. 15 minus 1 is the square root of 14. Can't simplify that any further. And on the right hand side, I have 2 times 3, which is 6, and 6 plus 8 is also 14. So I have the square root of 14 equals the square root of 14. So that checks, and that's in my solution set. For number 12, we don't have this radical by itself, so we need to move these other things to the other side. When we subtract 2 from each side, those are going to cancel, and we have the square root of 6x minus 5 being equal to x. We square both sides. 6x minus 5 is x squared. Let's set that equal to 0, and if we can't factor it, we'll use the quadratic formula, but it looks like we can. X minus 5, x minus 1, 5, and 1. So let's plug in the original equation and see if 5 checks. So on the left hand side, I need to make this a little bit smaller. On the left hand side, we've got 6 times 5 minus x, which means minus 5, plus 2. And the question is, does that all evaluate, does this all simplify to 2? So here I've got 30 minus 5, which is 25. And the square root of 25 is 5, and 5 minus 5 is 0. So since these guys cancel and 2 equals 2, the 5 checks. Let's plug in the 1 and see if it checks. Six times 1 is 6. 6 minus 5 is 1. 1 minus 1 is 0. And 0 plus 2 is 2. And hey, that equals 2. This guy checks. So both of these satisfy the original equation. Looks like that's it. So hopefully that excuse me. Hopefully that helps. Like I say, on a few of these, if I've done it kind of fast like this one, just take the time on your paper to come over and construct a table, and I believe that you'll see that I'm right when you use your table. So if you still have questions, let me know. Hope this helps. I will talk to you later.